Now let us solve the questions based on location of roots. So here is the first question. If the roots of x square minus 2ax plus a square plus a minus 3 equal to 0 are real and less than 3, then find the values of a. So here we have to find all the possible values of a which have the two roots of this equation to be real and less than the value 3. So first of all, we observe that the coefficient of x square is 1, which is positive. So that means the graph of the quadratic expression on left hand side, this will be a parabola which will be opening upwards. So let us try to depict that first. So this is the particular graph. Now we want that the two roots, let's denote them as say alpha and beta, to be less than the value 3. So 3 must come somewhere to the right side of the bigger of the two roots beta. Now here let us write down the conditions for this particular case, that is when the two roots are less than a particular constant. Say here it's 3. We know that first of all a must be positive, and here we see that a is 1. So that means this condition is taken care of. Now next is the discriminant must also be positive to have two real roots. So let's see what do we get if we evaluate this particular condition. Now discriminant is b square minus 4ac as per the original formula. So here we have minus 2a the whole square minus 4 times. See, the a square plus a minus 3 itself is the constant term. This whole thing to be equal to greater than 0. So that is we have 4a square minus 4 into a square plus a minus 3 should be greater than 0. So cancelling 4, we'll also see that a square also gets cancelled. So finally we are left with minus a plus 3 is greater than 0. So 3 is greater than a. So that means a is less than 3. Now just note that here they have not mentioned whether the roots are equal or unequal. They are just saying that the roots are real. So we may consider a case where the roots are equal, in which case we will have delta equal to 0. So that means this condition will get modified to a less than or equal to 3. So let's keep it here. Now another condition is that if we look at the value of the function at 3, then it must be positive. So we must have f of 3 to be some positive number. So therefore if we put x equal to 3 in the given expression on left hand side, so we have 3 square, which is 9, because this is where we are substituting x equal to 3. So 9 minus 2a into 3, which is nothing but 6a, and the rest of the expression is in a, so that will appear as it is. Now this we want to be greater than 0. So therefore we have a square minus 6a plus a is minus 5a, and 9 minus 3 is plus 6, which is greater than 0. So here we will see the factors as a minus 2 and a minus 3 to be greater than 0. So by wavy curve method we know that either a must lie to the right of 3 or to the left of 2. So it gives us either a less than 2 or a greater than 3. So this is the particular condition that we have to use. Of course we also must have the third condition as this minus b by 2a should be less than 3. So let's see what happens if we use that condition. Now here b is minus 2a whole upon, now here 2a is nothing but 2, and this should be less than 3. So cancelling 2 and minus becomes plus. Here we have a less than 3. Now incidentally it is already taken care in this condition, so there is no need to consider this particular last obtained condition as it's already present. So that means we have to now merge and write a final condition among these conditions. So if a is less than or equal to 3, this must be satisfied, and we also must satisfy the second condition, that is a has to be less than 2 or a has to be greater than 3. Now if you consider that a less than or equal to 3 and a greater than 3, they are contradicting, so they can never be true simultaneously. So that means we are left out with the only two conditions, as a should be less than or equal to 3 and a has to be less than 2. So therefore, merging both of them, we have the final condition that a must be less than 2. That's the condition which satisfies all the restrictions in the given problem. So therefore the answer is a should be any value less than 2. Let's move ahead to the next question now. Find the value of a such that it lies between the two roots of equation 2x square minus 2 into 2a plus 1 times x plus a into a plus 1 equal to 0. So here once again let us try to draw the graph first, because that will give us a fair idea of the conditions. We observe that the coefficient of x square, which is a, is 2 here, so it's positive number. So therefore the graph will open upwards. Now here we are given that a lies somewhere between the two roots alpha and beta of the given equation. Now to have some constant lie between the two roots, let us try to recall the conditions for this particular situation. Now we are given the case that a is greater than 0, so we know that parabola opens upwards. We also must have delta to be greater than 0 to have two distinct roots. Now here we want specifically two distinct roots, that is not just two equal but distinct, because the value a has to lie between them. So now if we consider delta greater than 0, let us see what does that lead us to. Now writing the value of delta, we have minus 2 the whole square, which is 4. Then we have 2a plus 1 the whole square, so this is that b square, minus 4 times a into c, so that is 4 into 2, which is 8a plus 1. This we want to be greater than 0. So cancelling the factor of 4, we have 2 here. So 2a plus 1 the whole square is 4a square plus 4a plus 1 minus, here you have 2a square minus 2a greater than 0. Now further we have 4a square minus 2a square, which is 2a square, and 4a minus 2a is 2a plus 1 greater than 0. Now here if we see this particular quadratic, now in a will be obviously always greater than 0, because if we see the delta of this particular quadratic expression is 2 square, which is 4, minus 4 into 2, so that turns out to be minus 4, which is negative. Now when delta is negative for a quadratic expression having positive coefficient of x square, will represent a graph something like this. so that its value will always be positive because it lies above the x-axis. So in other words, we need not worry about what value of a, because this particular expression is already or always satisfied. So now let's move ahead to the next condition. Since we have confirmed that delta is greater than 0 has been taken care of. Now here we have another restriction, that if we consider the function at the value a, then it should have the negative value. That means we must have f of a to be a negative number. So putting x equal to a in the given expression, we have 2a square minus 2 into 2a plus 1 times a plus a into a plus 1 has to be negative. So let's collect all the a squares. So that is 2a squares minus 4a square plus a square. Now let us collect the a terms, which is minus 2a and plus a should be less than 0. So 2a square plus a square is 3a square minus 4a square is minus a square minus a is less than 0. So multiplying by minus 1, we have a square plus a. Now the inequality will reverse and will have greater than 0. And taking a common, we have a into a plus 1 also greater than 0. So that means here by wavy curve method, a is either minus 1 or 0 to make these factors 0. So that means since we want the expression to be positive, either a has to be bigger than 0 or a has to be less than minus 1. So here we have a less than minus 1 or a bigger than 0. So this is the final answer for the value of a which satisfies given conditions. Let's move ahead. If the two roots of equation x square plus 2 into k minus 3 times x plus 9 equal to 0 lie in the interval minus 6 to 1, then find the values of k. Alright, so once again here we note that the coefficient of x square is 1, which is a positive number. So if we draw the graph, then it will open upwards. Let's call the two roots as alpha and beta, and it's given that the roots lie in the interval minus 6 to 1. So that means minus 6 must come to the left of alpha and 1 must come to the right of beta. Alright, we note that the value of the function at minus 6 as well as at 1 should be positive. So now let's recall all the conditions for this particular situation, that is roots to lie between certain given interval. First of all, a greater than 0, for a greater than 0, this is already been taken care. Now we also must have the discriminant to be positive, to have two distinct roots. So if we write that condition for the given equation, we have 2 into k minus 3 the whole square, which is 4 into k minus 3 the whole square, minus 4 into the constant is 9. So this we want to be positive. So cancelling the factor of 4, we are left with k minus 3 the whole square minus 9 greater than 0. Now if you observe minus 3, when it is squared after opening the square, that minus 3 square will give us 9, which will get cancelled with 9. So we are left with k square minus 6k greater than 0, which gives us k into k minus 6 be greater than 0. And so if we plot the two corresponding values, since we want the product to be positive, either k has to be greater than 6 or k has to be less than 0. So therefore let's write down that condition: k less than 0 or k is greater than 6. So this is the first restriction that we obtained on k. Now let us see what else we have to say. As we have seen, the next condition we must put is f of minus 6 has to be positive. So let us consider that f of minus 6 should be positive. So let's evaluate that. Here we will get x square, that is minus 6 square is 36, plus when we put x as minus 6 we will get 2 into minus 6, which is minus 12. So that is minus 12 into bracket k minus 3 plus 9 should be positive. So therefore the k term is minus 12k. Then 36 plus minus 12 into minus 3, which is once again 36, which is 72, plus 9 is 81, is greater than 0. So that means 81 is greater than 12k. So cancelling the factor of 3, we have 27 by 4 greater than k. So that means k has to be less than 27 by 4. So here is another restriction on k. Now the next condition is f of 1 also should be positive, as we have seen. So let's evaluate that and see what do we get. So we have x square, which is 1, plus 2 into k minus 3, so that gives us 2k minus 6 plus 9 should be positive. So that means 2k, 1 plus 9, 10 minus 6 is 4, should be positive. So that means k plus 2 should be positive. So that means k should be greater than minus 2. So k should be greater than minus 2. That is another restriction we have. We also need to say that minus b upon 2a must lie between minus 6 and 1, because otherwise we may have both k1 and k2, which are the endpoints of the interval, on either side or only one side of the root. So to avoid that, we must write another restriction. So let us see what do we get for that. Minus b upon 2a, this must lie between minus 6 and 1. So therefore we have minus 6 is less than, minus of b is nothing but minus of 2 into k minus 3 whole upon 2, because a is 1, is less than 1. So 2 is cancelled, and if we multiply throughout by minus, we have 6 greater than k minus 3, which is greater than minus 1. So that gives us 9 greater than k greater than 2 if we add 3 throughout. So just writing it another way, we have 2 should be less than k should be less than 9. So k must lie between 2 and 9. So now we have these 4 conditions for k, and we have to see what is the final allowed set of values of k which satisfies all of these inequalities. So we will observe that the final set of values of k is nothing but k must belong to. Now here if we see, k is less than 0, but here we have k must be greater than -2. Then we have another restriction that k must lie between 2 to 9, so which automatically rules out all the negative values of k. So therefore finally k must lie between 6 and 27/4, because if you observe that 27/4 is just more than 6. So this is the final answer.